you take the SAT, whatever 2 little examples we do are posted in Canvas, and the expectation is that you copy that. Shouldn't take long. Okay. All right, let's crank through these real quick. I'm going to zoom in real tight. Just stay with me. Don't try to get ahead of me. You know, the notes are interesting. Sometimes kids are like, I want to hurry up and write the notes down. And then when you're doing that, you're not really paying attention to what I'm writing down. So I'll go slower. But I'm explaining why I'm doing what I'm doing, right? So I get it if you're absent and you want to write stuff down. But when I'm explaining it, you really want to focus and pay attention, okay? So remember, I want to make this look like x equals some stuff. All right. So I got to get x by itself. So I have an 8 here and I have a 3 here. And so I joke about PEMDAS, please excuse my dear Aunt Sally, but when you're solving, you kind of go backwards. So I wrote it on the board. It's SADMAP, which is PEMDAS backwards. Because remember, when you're solving an equation, you're undoing what's being done. So the order of operations changes. Now, it's not 100% of the time. There's just, over time, you learn it's more convenient to do things this way, and there's a more efficient way to do it. So normally, remember how I used to say almost always the 8 is the last thing you deal with? Well, now it's not. So normally if we were to do some sort of evaluation, I would do exponents and then multiplication. But because we're solving, I'm going to do multiplication and then exponents. So 8 is being multiplied by x. To move the 8, I'm going to divide, which is the opposite of multiply. Whatever I do on one side of the equation, I have to do to the other. 8 divided by 8 is 1. That leaves me with x cubed is equal to 64 divided by 8, which is 8. You guys are used to me asking questions. Before I can ask the questions, you answer. That's good. All right, so now I'm going to take the cube root. Because I have x squared and I want it to look like x to the first power and some stuff, I'm going to have to take the cube root because the root undoes the power. Now, whatever I do on one side, got to do on the other. So I'm left with x is equal to the cube root of 8. Well, if you haven't figured this out, 2 to the third power is 2 times 2 times 2. What's 2 times 2? 4. Times 2 again? 8. So really, the cube root of 8 is just 2. Okay? Any questions on that one? How many of you guys got that? Yay. All right. Let's move on to problem number 7. I'm sorry, were you guys done writing that down? I promised to go slower and then I went really fast, didn't I? Can we move on to the next one yet, or no? I still see a couple people writing some things down. Okay. Now? Yeah? Okay. Same thing here. Now this is basically the same thing, right? I've got the 1/2 and the 5 I need to get rid of. Okay? The 1/2 is really being multiplied by x. So this is a little trick. I don't know if you realize this. I can get rid of the 2 in the denominator. We don't like fractions. We don't like fractions. So what is the 2 doing to the x, technically? It's dividing. So since it's dividing the x by 2, because 1/2 cuts things in half, right? It's dividing by 2. If I have one pizza and I cut it into a half a pizza, I'm dividing the pizza into 2 equal parts, right? So the opposite of dividing by 2 is multiplying by 2. So what's 1/2 of 2? Just 1. 1 times x to the 5th power is just x to the 5th power. Now 2 times 512 is 1024, right? Oops. Now, if you're not certain on those things, just do it on the calculator. 512 times 2, 1024. So that's right. So I know to get rid of this 5, which is a power, to undo a power, I have to do a fifth root. Whatever I do on one side, I have to do on the other. Now, I think I know what is raised to the fifth power that gives me 1024, but let's assume I have no clue. I think it's 4. But let's assume I have no clue. So what I'm going to do is I'm going to take my calculator. This is the quickest way to do this. I'm going to say 2 raised to the fifth power, 32. Nope, that's not it. 3 raised to the fifth power, 243. That's not it. 4 raised to the fifth power, there it is. 4 raised to the fifth power equals 1024. And you just, if you had usually in a high school class, we don't go beyond like 4 or 5 when it's raised to the fifth power. So you just keep going until you get the number or a number that divides evenly into it. 32 does go into 1024 evenly. But 4 to the fifth power is 1024. That's the process. 2 to the fifth, 3 to the fifth, 4 to the, until you find something. Okay, that works. So then this becomes x, and I just jot this down so you know this. 4 to the fifth power is actually equal to 1024. So we just have x equals 4. Now you notice when I first started teaching you this stuff to show you why and how this stuff works, notice that I'm skipping a step or two. And that's okay. As long as you understand that we found a number raised to the fifth power that equals 1024, then we're taking the fifth root of that, which leaves us with the base. Okay. Does everybody have this written down? Can we move on to the next one? We're almost done, guys. Halfway done. Now here, what do I deal with first? The 5 or the 4? If you were to guess, which one do we need to move away from x first, the 5 or the 4? I saw somebody throw up a 4 and I saw somebody throw up a 5. So just think about this. How do I move the 4? It's the fourth power, so how do I move it? Yeah, we take the fourth root of it. Okay. Now, how do I move the 5? I would have to subtract it, but right now it's in the parentheses. Technically, you could do whatever you want as long as you do it to both sides of the equal sign. We're going to choose to take the fourth root because it simplifies it. It's the most efficient way. It cuts out a bunch of steps. In order for me to take this 5 out, it is complicated because it's inside the parentheses and it has to be raised to the fourth power. Also, we do PEMDAS in reverse order. Exponents and parentheses. So normally you do the work inside the parentheses first and then you do the exponents. But remember, we're working, when you solve an equation, we're working in the backwards order. So you would do SADMEP. The exponents come before parentheses, right? How would you say that? Instead of please excuse my dear Aunt Sally, it would be like Sally, Aunt, dear, my, excuse, please. So anyways, we're just going to take the fourth root. That was a little joke there. Obviously you guys aren't awake yet because that was funny. And whatever we do on one side, we have to do to the other. So remember, when we take the fourth root of a fourth power, we're left with the base. So this simplifies to just x plus 5. And the fourth root of 16. Is there a number that we raise to the fourth power that equals 16? If you guys were to guess, what do you think it is? Yeah, I see a lot of people kind of doing this too. But let's double check. 2 to the 4th power is equal to 2 times 2 times 2 times 2, 2 times 2, 2 times 2, 4 times 4. It does equal 16. Also on your calculator, if you haven't memorized these numbers yet, you just start with 2 raised to the 4th. That's the process. Oh, no, not that. 2 raised to the 4th, right? And if that wasn't the number that you needed, try 3 raised to the 4th. And if that wasn't the number you needed, raise 4 to the 4th. And you just keep going through that process, 5 to the 4th, until you get the number that works. Well, we got the number that works on the first attempt. Okay, but that's the process. So, on the next line, I've got x plus 5 is equal to 2. Easy peasy. What do I do to move the 5 now? Subtract. Whatever I do on one side, I have to do on the other. I get x equals -3. I can't emphasize this enough, guys, on these positive and negative numbers. I know that all through elementary school, your elementary school teachers said, don't use a calculator. Probably even in middle school. And I agree with that. You guys should try to memorize some of these things. But at some point, we need right answers. There's so many steps in some of the math that you guys are going to do in this class. We need to make sure that they're accurate. So we should always double check. So I'm just going to say 2 minus 5. Yep, -3. Okay? All right, next one. What do you think we do now? Here. Oh, you know what? Did Mr. Adams forget something? What do you notice about problem number 18? What did I say about even roots? What are we supposed to do? We're supposed to put a plus or minus. So technically this is plus or minus. So -3 is one of them if I consider only the positive solution. But remember, I have to consider the negative solution too. So I'm going to say x plus 5 equals -2. Still subtract 5. Still subtract 5. And I get x equals -7. Whew. Man, I almost forgot that. So remember, whenever we take an even root, we have to consider the positive and negative root, right? Because technically this is supposed to be plus or minus because we're doing the even root. So just jot that in there like this, plus or minus, okay? Because what's -2 raised to the 4th power? If you're like, Mr. Adams, I don't get it. Go into the calculator. This is why. What if I do this? In parentheses, -2 raised to the 4th power. Still positive 16, so we can't ignore that. Not in Algebra 2. Okay? All right. Phew. Almost made a mistake there. All right, we're almost done, guys. Over here, we're just going to take the cube root to undo the power of 3. That leaves me with x minus 2 equals negative. Oh, we got to do it on this side too. Cube root of -14. Again, we go to our calculator and we go, all right, what is 2? Well, we know it's probably going to be negative, right? So we would say in parentheses, -2 raised to the 3rd power. Does -8 go into -14? Does it divide into it evenly? No. So then I'm going to have to do -3 raised to the 3rd power. That doesn't go into it either. So we're just going to have a decimal approximation on this bad boy. Now we don't need to do plus or minus because 3 is an odd power, so I'm just going to add 2 here, add 2 here. 2 and roots, they're not like terms. So it would be, well, they are, but this is going to be some wild, crazy, irrational number. So we're just going to let the calculator do the work on this. This is positive. And we just plug that in the calculator. So I'm going to say 2 plus, remember we hit the math button. We're going to scroll down here to number 5. And then I'm going to take the cube root of negative 14, hit enter. And I've got negative, if we round to 2 decimal places, it's negative 0.41. So x equals negative 0.41. Okay? I'll leave that up. Oops. Let's make it fit. Not too shabby.